a lot of you might know that I'm a really big fan of using VR and AR in the way we teach and to be able to deliver content to a lot of different people in a lot of different ways. One of the things that, of course, we struggle at as a training school is being able to get people in near to real life situations where they have to do things or make decisions when maybe you're on either side of the world to what we are in the UK. One of the ways that we're looking and we're moving forward with bridging that gap is to move to VR scenarios, which you can get during your courses with us as distance learning material. So in these cases, you log into our LMS, upload your scenario, and work your way through it. The feedback you get, the questions you asked are all stored. We can see your pass and fail marks, and then we can tailor further learning to be able to meet those areas of demand. So what I wanted to do is show you a very sort of quick opening few minutes of our oxy-fuel welding scenario and show you how this is used in order to meet that requirement. So if we jump over here, what we're in here, we are in our scenario. Okay, what we've got is we're on site. We can look around. I am on just directly into the computer, but you can be on your Oculus as well if you've got an Oculus. We have a way of being able to drop in there, but I can walk around. So here I am in our scenario. Right, I tell you what, I want to make this a little bit bigger. There you go. So one of the questions we get a lot is, yeah, it's great to have training and it's all book based, but how do we show people how to behave and how to work through on our site? How do we get them to have real world situations where we can test them in a safe and controlled environment? Well, one of the ways we can do this at Carbon Arc is to use VR with purpose-built scenarios in little mini worlds which you can walk around as a student, answer questions, learn, make mistakes, do all that type of thing, and not have any issues. And this is one of the biggest things about VR, which has me really excited. So what I want to do is show you the opening sort of couple of minutes of our oxy-fuel welding scenario and get your feedback on what you think it looks like. So if we jump into the scenario here, where we are is I am just in a web browser. So I logged into our LMS, selected our scenario, and this is where we currently are here. So I'm moving around here. So right and left on the D-pad, up and down on the D-pad to look around. And then I'll use the WASD keys to move and strafe and do all that type of thing, right? So we've got an activity here in the bottom left even, which is saying, engineer arrival. So this is our current task and what we need to do, right? So we're arriving on site, we need to go and see the engineer. So here is the this little bead here tells us where we need to hit. So I'm going to go to there, just walk myself across. So I can look at here, select my thing to begin work, right? So we've got a scenario, a question, things to do. So in the office, there is a design specification for a component which is incomplete. You will have to calculate the mission dimensions, right? Okay, so now we've got a little dot there to say we need to head that way. So what I can do is I can get myself up to that position. Okay, so we've got an office. Okay, so we can come to here. So we've got our drawing, our design. Again, click here. What's going to ask us next? Complete the drawing specification. Okay, right. So using Pythagoras theorem and a calculator, record the slope height of the panel side. So we've got a drawing. So we're making a cone, for lack of a better word. We've got some information here. Can I do this? Right, so I can zoom in on it so we can see it bigger. So, it's 250 mil at the bottom, 100 mil at the top. We've got, calculate the slope height using Pythagoras. So here we're given some dimensions. So what we got? We've got 250 squared times 75 squared equals the slope squared. Okay, so we can do that. Now, I've kind of already worked it out. So what I can do here is I can drag it along. And off the top of my head, I think it's 261. Let's submit that answer. There you go. So we get feedback. We correctly identified the slope height because I used Pythagoras theorem, which is a squared plus b squared equals c squared. But it gives you a calculator and things to work your way through. So we got that right. That's brilliant. Okay, next one. Please go to the next room and put on your personal protective equipment. So this is one of the things, is moving around a site. I know it's not perfect, but it is better than nothing. This breaks the monotony of a classroom and what we're doing. So again, it's our workshop. So we can go through, and here's our changing room, Okay, we've got our things here. So we've got our PPE. Right. From the following list, please select the items required for oxyacetylene welding. Now, we got our last question right, so let's have a look if we get something wrong. So what do we think we need for oxyacetylene? Well, definitely some welding goggles, right? I need a flame retardant jacket. We need some leather gloves. Okay, it says do all three. What happens if I get one wrong though? Okay, so we're not going to use goggles. We're just going to try and stare at the flame as we weld. So if I submit that, you can see there. So the flame retardant jacket was correct, but our leather gloves and our over boots or spats is wrong. So we get a little bit of feedback, says it's not quite right. In order to protect you from infrared radiation and the heat, you should be wearing goggles. Right, so it's there, right? A flame retardant jacket, and if seated, an apron, right? So there you go. That is now going to be logged that I got these wrong, and we'll be able to look at it later. So we're going to put that on. You'll see those bits of correct PPE are now missing. Right, so within the drawing specification, now complete. Start again. With the drawing specification now complete, move into the workshop and lay out the panels. So now we've completed our calculation for our drawing. We've selected our PPE. We get our next task. So the next one here is, with the drawing specification now complete, move into the workshop and lay out panel templates. Okay, so right, we're going to look for that cross somewhere that tells us where we need to go. So this says go to the workshop, so let's head down in that direction. Oh, there's a cross there in the middle, so we can come to there. All right, so now we've got a layout of our templates. So these are from our drawings, so let's have a click on here. On the workbench, mark out panel templates using the nesting technique. So nesting technique is where we pull the samples, or the bits we want to cut out, is close together and make the best use of our material. Okay, you get the efficiency in out of your material really. So here we go. The layout should achieve at least 85% efficiency. Press a piece to interact with it and move the pieces. So all right, so I can move my pieces round. and I can rotate them like this, right? So, right, how do I get my efficiency? Now, what I'm going to do is I'm going to bring that to 0. I think I'm going to put it in the bottom there as far as I can. Make that 180. Then I want to bring that probably to there. Bring my next one in. Get them close together. Of course, accounting for however we're cutting it. If you need a little bit of green on the ends or whatever. 180. Let's bring that back in there as well. Okay, so I don't use any of this material, just a bit at the bottom here, and then I can go submit. So I'm happy with how I've laid them out. Okay, it says the layout efficiency based on your arrangement is 91%. Great. Maybe I can put them straight up against each other, but of course it depends how we're going to cut it. If we're cutting it with a grinder, then we'll need a little bit of gear. But if it's on a guillotine, we might be okay. So we get that. Right, so move on to our next task, and so on. So you can see here how we're getting multiple different ways of asking you to show your knowledge in a fabrication environment. So here we've got a little bit more. So that was a very brief look at our LMS and how we can bring you into the workshop even when you're at home at your computer. This is one of the ways that Carbon Arc is moving forward to make sure that your learning is as interactive and as thought-provoking as possible. This allows us to test your knowledge before you come anywhere near our workshop. Imagine Carbon Arc's workshop in this scenario where we could maybe build an introduction so you know where your fire points are and how the safety considerations and where you need to be day to day before you even come to our site. That's just another one of the possibilities when we work in these 3D environments. So if you've made it this far through the video, thank you. I really do appreciate your support. Here's where we get to offer you something. We're looking for 5 people to join a small development team, right, to help give us feedback of real life users through their use of our system. In return, you will gain the 4 VR scenarios absolutely free by logging into our LMS from wherever you are in the world. And I'm looking for people from all over the world to get involved in this. If this is of interest to you, drop me an email at info@carbonarc.co.uk and say that you want to be involved, drop your CV in, and then we can go from there. I am looking for people who have just started their journey through weld inspection and those who have been in it for a while. Okay, so with that, I hope to see your email in our inbox soon, and as always, good luck with your studies.